The third unit is an engineering curve. So we have a 10 different type of curves in our syllabus. Out of that, first section is a conic section. So conic means what? You can see this is the diagram which is having a cone here, and these are nothing but the position of the cutting place. So on the basis of the position of the cutting plane which cuts this cone, we are getting a different type of the shapes here. Now in the first diagram, you can see this cutting plane is parallel to the base of the cone. So whenever this cutting plane will cut this cone parallel to the base, then the shape we are getting will be a circle. Okay. Similarly, if this cutting plane is inclined at a 45-degree exactly at the midpoint of the axis of a cone, then the shape we are getting is an ellipse. So, and third is when the cutting plane is parallel to one of the generator. These are the generators of the cone which generates the cone. So whenever this cutting plane is parallel to the one of the generator of the cone and it is cutting the cone, then the shape we are getting is a parabola. Okay. Similarly, when this cutting plane is perfectly vertical, or we can say that it is parallel to the axis of the cone or perpendicular to the base of the cone, then the shape we are obtaining from that cutting is a hyperbola. Okay, so these are the different conditions of getting a different type of the conics, and these are depending on the position of the cutting plane over the cone. Okay, so let's start with a first conics, that is an ellipse. So we have two different methods of an ellipse to draw in our syllabus. First method for drawing the ellipse is a focus directrix method. This method is also termed as a general method. Okay, so let's start with the first problem based on the focus directrix method of an ellipse. So this is the problem. You can see a focus of an ellipse is 50 mm from the fixed straight line. Draw an ellipse by focus directrix method when its eccentricity is 2 by 3. Now we all knows what is meant by eccentricity and what will be the conditions of that eccentricity for ellipse, parabola and hyperbola. We know that when the eccentricity will be less than 1, that will be definitely a conic, that is ellipse. Okay, if it is equal to 1, then the curve we are obtaining from the cone will be parabola, and if it is greater than 1, then it will be a hyperbola. Okay, so here we can see the eccentricity is 2 by 3. That means when we divide this numerator with the denominator, we are getting the value less than 1. That is condition for the ellipse is satisfied here. Okay, so the curve which is given here in the problem is an ellipse. So to draw that ellipse, we have given with one given data here that the focus of an ellipse is 50 mm from the fixed straight line. That fixed straight line is also termed as a directrix. Okay, that's why this method of drawing an ellipse is termed as a focus directrix method, because the directrix and the position of the focus of an ellipse is given. Okay, so let's start with the drawing. So we'll start with the vertical line which is given here, and that is called as a directrix. So this is a vertical line and it is termed as a directrix, and it is denoted by these letters DD. Now take any point C over this line DD or directrix. So after that, draw one horizontal line perpendicular to the directrix to locate the position of focus from this fixed straight line. Now what is given here? The focus distance from this fixed straight line, that is the vertical line, is given. Now we can locate this focus at a 50 mm distance from the point C over this horizontal line. So locate that point here. So this is a focus at a distance of 50 mm, which is given in the numerical. Okay. Now next, we need to find out the any one point over the ellipse here, and that point will be always lies in between C and F. But we need to locate the exact position of that point. So that point is known as a vertex. Now to exact locating the position of the vertex, we have given with an eccentricity of 2 by 3. Now in a graphical method, this eccentricity is the ratio of distance of vertex from the focus to the distance of vertex from the directrix. Now if you assume that the position of the vertex is here, then according to the eccentricity, the distance of vertex from the focus, that is this one, the VF, to the distance of vertex from the directrix, that is VC, that will be the ratio. Okay, so we can say that the eccentricity is Vf upon Vc, and its value is given here 2 by 3, so we can write down that value. Okay, now to locate the exact position of the vertex in between C and F, we need to add this numerator with the denominator. Okay, that is Vf plus Vc, and in this diagram Vf plus Vc is nothing but this complete segment Cf. Okay, similarly we need to add these 2 plus 3 here. This is the summation of 2 by 3, 2 plus 3, and Vf plus Vc is nothing but Cf, and 2 plus 3 is equal to 5. Why we are adding this? Because we need to divide this Cf line equally into the part we are getting from the summation of this numerator and denominator. So here 2 plus 3 means 5. So we have to divide this complete CF line into 5 number of equal parts, that is 10 mm of each, right? So we'll divide this CF line or segment in 5 number of equal parts of 10 mm of each. Now we are able to locate the exact position of the vertex here. Now if you see the eccentricity again, the vertex is 2 part away from this focus, you can see, or we can say that this vertex is 3 part away from the directrix. So you can use either of this. So I'm taking this one. The vertex is 2 part away from the focus. So measure that part from the focus, 1 and 2, right? So the exact position of the vertex will be here. Now locate the vertex point here, and this is nothing but a starting point of an ellipse. Now next step is to draw a vertical line passing through this vertex or point V. Okay, that should be perpendicular to this line CF or parallel to the directrix. Now take a distance equal to VF in a compass. Put one leg of your compass over V and draw an arc over this vertical line passing through the vertex. That will be your point E. Okay. Now join this point C with E one line and extend that line further. So join this C with E with a line and extend it further. And the next step is from the focus, draw one line inclined at 45 degree. Okay. So that will be the second step. And you have to draw this line till it intersect the line passing through C and E. That point of intersection is denoted by point G. Now from this point G, draw one perpendicular over the horizontal line CF. This will be nothing but a second point of ellipse, V dash. Okay, and the distance between V and V dash is nothing but a major axis of an ellipse. Now next is we need to divide this major axis into any number of parts. It may be equal, or you can randomly mark the points over this line between the V and V dash. Okay, so I am dividing this VV dash into 13 number of points. So this is 1, 2, 3, 4, 5 up to 12, and the V dash will be a 13 point. So you can take any number of points here, you can reduce the number of points, you can increase the number of points. So it is recommended to use 10 to 12 number of points for ellipse. Okay, so divide this V dash into 12 number of equal parts, or you can mark it randomly over that line. Now next step is draw a vertical line passing through all these points till it intersect the line CE, like this. The vertical line passing through 1, it will intersect line CE, and the point of intersection is 1 dash. Secondly, the vertical line is passing through 2, it will intersect CE here, and the point of intersection is 2 dash. Likewise, Draw vertical line passing through all these points till it intersects the line CE and mark the corresponding point with a dash. Now next step is you need to take this 1 1 dash, that is the vertical distance 1 1 dash in your compass, put one leg over the focus, that is focus as a center, and draw or cut an arc over the same line 1 1 dash from both sides. See, that will be your first point of an ellipse from the both sides, that is designated by the P1. Now for locating the second point, take a vertical distance 2 2 dash, this one, and again taking the focus as a center, draw and cut arcs over the same line 2 2 dash from the both sides. See, that will be your second point. For getting a third point, take this vertical distance 3 3 dash in compass. Always take focus as a center and cut an arc over the same lines, that is 3 3 dash, for getting the third point of an ellipse. Likewise, take all the vertical distances in the compass, and by taking the focus as a center, draw the corresponding arcs over the vertical lines for getting 12 number of points. Okay, like this. So we have got 12 number of points and the V dash will be our 13 number of points. So now we have plotted all the points of an ellipse. Now just we need to draw a smooth curve passing through all these points, and that will be nothing but an ellipse.